Hey there, today I'm going to show you how to use Unity's multiplayer dedicated server system in Matchmaker. It's actually really easy to use. There are a couple pitfalls that I ran into though. I'll show you how to get past them and how you can have this up and running in just a few minutes. We're going to use a very simple game so that way you can put in whatever game you want and it'll be really netcode agnostic. I'm using netcode for game objects here, but it would work with any netcode system. The whole point of this thing is to get servers up and running, get players match made into different matches and games, and then have them connect to those servers automatically. You can do filters and all kinds of other interesting things, but we're going to stick with the basics, and I'm going to show you how you can easily get it working and have backfill working as well, so that after your match has started, players can keep joining in and keep filling up the game so that you don't have a server where all the players leave and then it slowly dies off. There may be a lot of game scenarios where you want that though and you don't use backfill. If you just want a match where everybody's pre-matched at the beginning and then at the end of it that's over, kind of like a League of Legends or any team-based type thing, then you wouldn't want to do backfill. So we'll worry about that right at the end. Let's start with the basics though. Now, for my implementation of these services, of course, I'm going to be using Unity, and I'm using 2023.3, which will eventually get renamed into Unity 6, I believe. And we need to install 3 packages. There's the authentication package we're going to need, and we're just going to use anonymous authentication to log in for now so that we have separate accounts for each player that logs in. We need the Matchmaker package right here, which is responsible for getting players together in queues and putting them into a pool and then sending them off to a server. And then we need the multiplay package as well, just for the dedicated server hosting side. So once you have all 3 of those installed, let's take a look at what we'll need for a scene setup. Now, the way that I like to do things is have a simple startup scene that my game can load into and then figure out what it needs to do from there. In this startup scene, I've got a simple startup script with the name of a client and server scene here. I made this very flexible and very simple, so when you download the code, you can use it however you want, and you can very easily see how everything is tied together. Nothing really hidden here. So let's open up the startup script. You'll see here in the startup script, I don't do much other than check to see if we have a command line argument where we're passing in a port. If we are, just assume that we're the server, otherwise we're the client. There are a million different ways that you could do this check, however you want to do it. Just load into the correct scene. And I load into either the server scene or the client scene. Now, before we get too deep into code and configuration on the dashboard, let's take a look at these scenes. First is the client scene. The client scene just has a canvas with a little text object named status text, absolutely nothing on it. And you'll see that the code just looks for the only text object in the scene and then writes to it just to give us some little update. And then we've got a client script or a client object with a single client script on it. The server is pretty similar, it just has a server script. And then here we have an example server query handler. And this is actually from one of the Unity samples that is pretty close to what I would say is easy to use, but it had a little bit of extra complicated stuff in there, so I ripped a little bit out. And you'll see it, but I wanted to leave the name in there and not merge it all in there, so that way you can see the bigger version just by going and looking at the example server query handler that they have posted on the page. Now, the last scene that we have is the one that the players load into when they connect, which is just level 1. It has a little button here to leave and then a text object, and then it's got a plane on the ground. So if I go into 3D mode, you can see that it looks like a 3D world. But before we get into the complicated stuff of our clients and servers and how they all connect, let's take a real quick view of the scenes. So we have that startup scene, and then on our clients, we're going to have them load right into the client scene. So go into client. And on the server, we'll load into a server scene. Now, when the client connects to the server, or when the server starts up, really, it's going to load up level 1, and then that's going to be done with the network scene manager so that when the client connects, they'll automatically load right into level 1. On the client scene, they're going to go around and search, so they'll search for match. I can't spell search, but you get the idea. And on the server, they're just going to say, hey, we're ready for match. And it'll tell the server system that it's ready and then take players. And let's take a look at the flow real quick of how this all works. And then I think that'll make more sense before we jump into the code and again, the config stuff, which is really simple as long as you don't mess it up like I did the first time. So here you can see you've got multiple clients. So if I want to start a game, my clients will first reach out to the matchmaker. matchmaker. The matchmaker will tell it, or will look and wait until there are enough clients to start up a match. So right now, if my matchmaker says, hey, games have to have at least 2 players to start, then when 1 player connects, it's just going to sit there and keep waiting and waiting and waiting. And then as soon as a second player says, hey, I'd also like to join, now there are enough players to get in, it'll connect to the object or the server that's over there on Unity side that's doing allocations. That'll spin up a new server, our game server, and I'll show you how we'll set that up and how we'll upload that in just a moment. It'll spin that server up though. Once that server's done, it'll tell the matchmaker that it's up and ready. There's actually a call that we're going to make that says, hey, matchmaker, I'm ready for players. The matchmaker will then, actually I should probably turn this object around because it's kind of bi-directional, tell the client, hey, go connect to this server. It'll give it the server address and the IP, and then the client will connect, and so will this client. This one will get that same connection right there, and then they'll be connected to the server, and that's how it all ties together. And if we set up the backfill, of course, then what'll happen is if client 3 comes in, it'll go try to connect to the server 1. If we don't have backfill on though, and this match is already started, then client 3 would get sent over to the next server. Server 2 would get allocated and started up. So again, it's a lot of talking, a lot of lines. Let's go look at how it works. Now that we've examined the scenes, let's take a quick look at our build settings, because this is another part that could be very confusing if you haven't done it before. When you're building a dedicated server build, at least at the current time, the servers only support Linux, and realistically, you usually want to use Linux because it's generally cheaper. It tends to be about half the price to run a Linux server as it does a Windows server, primarily because of licensing costs. So you're going to want to do a Linux build, which means that you're going to need to have the build profile for Linux enabled. This is the Unity 2023.3 version. If you're in the older versions, just go to find Linux, and then you should see an option to install with Hub. Don't do Mac, do Linux server, or dedicated server is the option in the older versions. In this one though, it's just Linux server. Install that, and then you're going to need to do a build. Now I'm going to show you the code that you'll build in a moment. First, I want to show you the process. I'll show you the code. You can download it all and then upload it. But to do a build, just hit the build button, and then I like to just create a subfolder off of my projects folder named build and build into that. So this is a multiplay/build folder. You see I've got my assets right there. Go into build, I hit save and hit yes. It's going to create a new build, and it's going to deploy it out to that folder. And in just a couple of seconds, I'll get my Windows Explorer window popping up. It's probably a little bit different on a Mac, but you get the general idea. Do a build, and then we're going to set it up and deploy it into the dashboard. There we go. It actually just popped up, and you can see it right here. Now let's go over to the Unity dashboard. Here I'm in the gaming services matchmaker side, and I've got a project named Multiplay, which is actually the name of the game server hosting, or it was the name of it. It's getting renamed and changed around, but that's just my project name. You can see my other projects right here, starting with some old 2018 ones. And then over here on the left, I've got the options for different things that I've been to before. But if you just go to dashboard, then you can find your project, select your project, and eventually get to your game server hosting section. Enable game server hosting, and then the first thing you'll need to do is create a build. So you go to the build section, and you can see I've got one here named test. I think that's a great name for one. I'm going to create a new one though named test 2, because I can't have 2 of them with the same name. So create a build, and I'm going to name it test 2, and we'll leave it as a Linux build because, well, 1, it's the only option, and 2, like I said earlier, it's drastically cheaper. It's about half the price, and we're going to leave it on direct file upload. You can use these other options, but direct file is pretty easy, and I think probably the simplest. There's also a deploy option, although I think it may only work from Mac. I haven't been able to get it working on Windows yet. That'll let you deploy straight from the editor. So here we're going to choose folder upload, and then we select that folder. You see I've got that folder right here. I just hit the upload button, hit upload, and then hit upload again, and it's going to upload all of these different files. So it's going to get all of the files in there and then figure out which ones are changed and replace the changed ones. So we'll see that happen live right here. Just takes a moment. And then we're going to be able to deploy out these changes to all of our servers and have that happen automatically. Now, I want to mention something real quick here. When you want to make a new build, like you have a new version of your game, you do not create a new build here. That I'm only doing this just to show the process so that you can see how you step through and how you create it. I've created that build. That's cool and all, but I actually don't need a second build. So I'm going to go back to builds, select this one, and delete it. Now to update a build, you see here I have my build named test. It's actually on version number 24. If I click on it, I go to files and I go to update files. Here I can hit update existing files. I can search again, hit folder upload, select that same folder. And then it's going to allow me to upload those files to this build. Let's see, as soon as it pops up, there it is. And then it's going to update all of my servers that are running this build. So don't think of a build as like a build version or a build that you've released. Think of a build as more of a build configuration. There's another thing called build configurations underneath, so it's a little bit confusing. And it's one of the things that caught me up the first time I saw it. I wasn't really thinking straight about it and made 2 or 3 builds, and I was like, wait a minute, this doesn't make sense. We make one and we update it, and it'll just keep rolling out. And you'll see how that works in just a second. As soon as this finishes uploading, I can hit next. And then I've got an option here to either progressively roll out my builds so that when servers go down, they'll come up with the new version, but I don't kill them all. Or I can hit forced, which will just kill off all of my running servers and force them to update right away. I'm gonna hit forced because I'm not in a live production environment, even though my environment is named production. Once you do that, it's going to sit in a syncing state for probably a minute, probably a lot more if you have a big project. This is a relatively small one, just to keep our times down and keep everything fast. But we've got a build done. Next, we're going to need a build configuration. Build configuration, I've also named test because I just like to keep the name nice and simple. And to create a build configuration and do the same thing. I'll just create one here, name it test 2. You select your build. So here you just name yours test. And then you select your game server executable. And if you just search for x86, there you go. You should see this one, the .x86_64. That's the build for your Linux executable for your server. Leave this on SQP. And then if you scroll down, I don't think you need to really change anything else. Everything else can stay default. You hit next, and then you can optionally add variables. You don't need to do this either. Again, keeping it bare minimum. You can hit finish, and now you've got a build configuration. Again, I already have one, so I'll just go find that one, and I think I'm gonna actually delete it, and then we'll continue on with the next thing. Once you have a build configuration, you need a fleet. And a fleet is a set of servers, or it's like a set of build configurations to server mappings. Let's show you what the settings are real quick. We hit create fleet. We give it a name, test 2. It's still Linux. We select our build configuration. Let's see. Oh, apparently I can't do it right now because I deleted that other build configuration. So I'll go create it again. All right, there we go. I recreated it. Now it shows up in the list. I hit test 2, and then I hit next. And then it's going to ask me what region I want these servers to be in. So I'll pick North America since that's where I'm at. I'm going to set it at a minimum of 1 server and a maximum, or actually I'll set it at a minimum of 0 servers and a maximum of 1, which is a good number to have. So that way, if you're not running anything, you're not being billed for it. Set it down to 0. Now, our max servers is up at 1, but that doesn't mean it's our max games. Our server can run multiple game instances. You'll see how that works in just a moment. I'm going to hit next. And then here, there's our settings. So servers per machine. Now, this is going to vary based on your game, depending on what your game requires. My game could, with this game, I could probably easily do 100. Now, it'd be pretty, well, I don't know about 100, but because the memory allowance per server would be a little low, but let's go with like 20. So it's going to be relatively low usage because I'm not sending much and my game is tiny. And this is going to scale with your game. So you hit finish, it'll create the fleet. And then we go over to machines. Now, when we're in the machine section, if I just look right here and look, I'm going to see that there's nothing there because everything is offline. But when I actually start to use this thing, it's going to bring up servers and they'll start to appear here. So let's take a look at how we can spin up a server real quick that has a build with our current build. And then we'll finally look at the code so you can see how that all works. So here's our test allocation section. If I go here, I can create a test allocation. I can select the fleet that I want. I can select the region to put it into and the build configuration, hit next, and then hit run test. What this will do is kick up a server and start that dedicated server build that I just pushed over onto the server. I'll show you how to look at that. We'll see it running real quick, and then we'll see the logs from it, and then we'll see how all of this ties together with about 50 or so lines of code, not counting debug. Probably less than that. It's probably closer to 30 lines of code, not counting all the debugs and just little curly braces. So here we go. We wait for the server allocation. And that's going to take a little while. If you look over here at the machines section, and here, let's click away and click back. So if I look at machines, you see that it says none, but I clear the online flag and you see that this new one is booting up. Once that finishes booting up, then my test allocation here should start up and it should tell me whether or not my configuration is good and my build actually started. This is a great way to just make sure that your build is working before you start trying to connect clients. Make sure that all of the kind of server side stuff is up and working. So let's double check it again. If I go over here to my machines and clear that flag, it's switched to awaiting setup. We'll give it just a second, and as soon as it's ready, we'll continue on. All right, it looks like our server's up and running, or the machine there. And if I click over to the servers tab, you should see that I've got one allocated, and it's in my test 2 fleet. And I can actually click on that server here. I can click over to the files section and actually view the logs. Now your Unity log is going to be this engine.log, and as long as it's not too big, you can just click on it and actually view the data here. So it says here that there's some missing prefab stuff, but it looks like my server's starting up and listening and getting ready for some allocation stuff. So let's take a look at code now. Let's start with the server side because I think that's where it's easiest to get confused. You see, I've only got, again, 4 files here: startup, game player, client, server. Oh, and then there's that one other one that we'll take a look at. So let's go to the server file first. In our server file, if I scroll over to the correct part, there we go. You see that we've got a single field for the ticket ID. This is for the backfill stuff. We'll take a look at that later. We're just going to look at start server first. In the start method, we kick off a coroutine for start server that is using the async awaitable syntax. You can use this instead of an IEnumerator. Don't try to do an async void here because it ends up throwing some errors on the server side. It's probably because it's a void instead of awaitable. I don't know exactly the reason, but kicking off a new coroutine here seems to make this work perfectly fine with all the async stuff. Again, I still get mixed up in there, so I'm sure everybody else, or some of you probably do too. Comment if you do. Anyway, let's keep going. So on line 24, we have a start server method. On line 26, we initialize Unity services. This is a super common thing that you have to do for any of the service stuff that you want to use. And then on line 27, I just grab the server config into a shorter variable so that we can set the transport connection data right down here without it being a giant long line. So on line 28, we grab the transport from our network manager. This is again using netcode for game objects. And I just set the connection data to be whatever port multiplay has assigned, because this is running on the server. It's running in multiplay's services. Again, that was the name before. Now it's Unity game server hosting or dedicated. I don't know the name. It's kind of in flux, I think. But this is the API call from the multiplay package that we got, and it gives us the server config, which has the port. So that way we know what port we're supposed to listen on. And you need to make sure to set this IP address to 0000, not whatever the public IP address that you see is. The 0 will make it bind to the local internal IP, and then it's going to use that other IP as the external one that it's going to connect to after it gets routed through however it's getting routed on the server side. After that, I just log out a line for what our transport stuff is so that we can look at that in our debug log and see what it was. You don't really need it again. Most of the extra stuff here is just extra logs so you can kind of see the process and flow as you're recreating this. Next, on line 32, if we're unable to start up as a server, we do a little log, throw an exception, and then we're pretty much done. The server's going to shut down and close itself out. Otherwise, we set up some callbacks for client connection and server stopped, and we just do a little bit of a log, so that way we can see, hey, when the client connects or when the server stops inside that log that I just showed you a moment ago. And then on 40, we load level 1 using the network scene manager. And this is, again, netcode for game object specific thing, just so that the server and client are in the same scene. Now let's get on to the dedicated server part, which is actually right here on 43. First, we have to set up a new callbacks event. We're going to have to pass that into this subscribe down here on 55. The callbacks event has a couple different, or it's an object that has a couple different events on it: an allocate, deallocate error, and subscription change. 2 of them we really care about. The other 2, we're going to just throw a log and ignore for now. Next, on 49, you just wait until the multiplay service is actually ready and loaded up. which it probably already is here, but I just get a little bit paranoid and then I wait because I'm on the server and debug logging it stuff. It's kind of a pain. So I wait a little bit here. This is probably unnecessary. The next part, however, is not. On 55. We call the subscribe to server events async and pass in that callback method. Of course, we do need to await it and we get an object back, but we don't actually need to use it for anything if we don't want to. Now let's take a look at the two important parts that I mentioned. There's the allocate and deallocate callbacks. You look right here on 59. First, I just do a little bit of a log, just again, so we can see it in the logs there because it's on the server side. Reading it from the log is kind of the only way to get it. And then we have to call this well, here, let's look at allocate first. On allocate on 68, we call ready server for players async. And this tells the multiplayer service, hey, we are now ready to start taking players. So if you have something from the matchmaker, go ahead and send it over to us. On deallocate, just does the inverse of that and says, hey, we're no longer ready. We're shutting down. We're getting closed down. Don't send us any more players. And that's pretty much all we need for the server side without backfill happening. We'll take a look at backfill in a moment. Let's go look at the client side next. Here's our client script. It's got a single field in it, which is an initialized field. And this, again, is probably not necessarily needed. It's just there so that when we want to reuse a client just for our testing, if we want to connect to a game and we want to leave and kick ourselves back to the client, that we know that we've already logged in and run the initialize async stuff right here in our start method. If you look here on line 18, if we haven't initialized, we call initialize async, grab a random profile, and then sign in anonymously. This is just getting a random account so that everyone is signed into a different account. If you sign in multiple players without changing the profile, especially if you're in multiplayer play mode, you're going to end up with a bunch of players that are all the same player and they won't be able to log in separately. So you need to switch profile to something, and at random is just a nice, easy way to do it. Then a mark initialize is true, again, so that when we leave the game and come back to the client, we don't rerun the initialization and then throw an error saying, hey, you're already signed in. You don't need to initialize. Next, we call start search, though. So we have this asynchronous start method, and we're awaiting start search. This part, totally fine to run async straight from the start method. Works fine, and it's all on the client. Easy to debug if something was going wrong. So our start search method first creates a list of players, and this is just a list of player IDs that are going to be searching. We're just going to search for the single player and not do like a group search that's trying to put multiple players in. So we create a list of player entries, and this is an object that comes with the matchmaker, and it has our player ID, and then we can put in whatever custom data we want. I don't want any. We've got an attributes where we can put in some filters for the types of matches that we want to find. Don't care about those either. And then we've got a queue name on line 37. On line 37, I'm setting the queue name to test. And then on 38, we create a create ticket options, passing in that queue name and my empty attributes. So we could put in like rank filters and other things like that here if you wanted to. Next, on line 40, we wait until we find a match. If we haven't found a match, we wait a second and then try again, and we just keep looping until we find a match. And we're passing in that list of players, which is, again, just our player, and then the options. And this is really just so that it can be a loop that goes on forever until we find an actual match. Now let's look at the find match method. First thing it does is very lazily grab the transport. Should definitely be getting cached somewhere. And then it calls this create ticket async. And this is going to create a ticket with the matchmaker service with passing in those players and options saying, hey, I would like to join a game with whatever options I've selected here. Say, hey, I'd like to join any game that's in that test queue. Now we do an infinite loop here on 49. While true, it's just going to loop until we break out of it. We wait for 1 second, do a little bit of a log saying, hey, that we're doing a poll. And what we're doing on line 53 is polling the status of that ticket. So we have our ticket response here. This is the actual ticket that we've got. And we've got the ID of it right there. And we just call get ticket async and pass in that ID. It's going to give us the status of that ticket, whether it's been rejected, timed out, it failed, or if it was found and successful. Next, on 54, and just make sure that it is an assignment and cast it as one. I don't think that's ever going to fail, but just the way that I wrote it. And then on 57, this is, again, another just to be very obvious, this is not production code. This is replace it with whatever you want to do here or comment out the logs. We set some text on whatever the first text element in the scene is, which for me is just that one little status text saying what our response was, and do the log there too. And that's just so that if I do a bunch of client builds and I don't have a debug log, I can just see it right up on there on the screen. Nice and simple. And then we go through, and based on the status, we either do one of two things. If we found a match, then we'll start up our client and use the assignment info's IP and port. So this is where we're getting that IP and port info back. It's coming back in that assignment. And again, that was in that ticket responses value being cast as an assignment. Once we do that, we should be able to just connect just like you do with any other connection. And again, if you're not using netcode for game objects, you just set your IP and port here and do whatever you would do to start your connection. Then I do a little bit of a log saying that we started it, and we add a log entry here for connection events. And I'm going to show you what this does in just a second. It's really just logging when a player connects and disconnects, how many players are there, so that you can see what's going on and make sure that your whole workflow is going. When you have a real game going with characters coming in, obviously you probably won't need that. You might do something else there though instead. And the other thing that we do if we time out or fail is just do a little bit of log and return false. Remember, if we return false, it's just going to loop back in. So that's all the code there that we have for the client. Remember, this is calling into the Matchmaker service, and we haven't taken a look at that yet. So let's go there now. Here's the Matchmaker service, and this is what it looks like after you've done a bit of testing. So you had lots of connection attempts and not a lot of matches, and then eventually started kind of getting that leveled out, and then did something weird here where I made a whole bunch of requests, and I think I sent them all at once really, really quickly. Anyway, the setup for this is pretty simple. We have queues, and queues have pools in them. Let's create a new queue. Here's my test queue. You've already seen that one. I'm going to create a test2 queue. And then it has a maximum number of players on the ticket. So let's say I want maybe up to 10 players. I think that was what I put for my max, right? Could be. And then if I click on this, oops, let's see. It says it's invalid. And you see it says it requires a valid pool before matchmaking can begin. So let's click on it. And we'll go over to the pool section. We have to create a new pool. Now the pool, I'm going to name test2 as well. And then it's got the name test2. And here I have to give it a timeout. So this pool is a group that people will be querying into, and they're going to basically wait for however many seconds before we send them a timeout that it took too long. Now I have mine set to 30 seconds. I think that in a real production game, you probably want to set this up to like 5 minutes or something so that people have lots of time to just sit there and wait, and they can wait and wait and wait. But when you're doing tests, I feel like getting that shorter time is much better. You can see what's going on. You'll see lots of timeouts, but that's fine. You'll kind of get used to it and then crank it up. So my recommendation is start at 30 seconds and then adjust it afterwards. Once you've gotten used to it, get the kind of core system working, you know that it's working before you wait, because you don't want to wait and see if it times out for 5 minutes. So you hit next, and then we choose our fleet. If I pick that new fleet, I can pick the new test configuration and the region. I hit next again, and here I've got to define our matches. So for this, I'm just going to name it test2 as well. And here's where I think you could define different types of matches, like 1-on-1, 3-on-3, or whatever type of thing you want, free for all. You decide what type of match you want. Here you decide if you want backfill enabled or disabled. And then you define your team. So you have like team 1, or maybe I make this team FFA and my match definition is FFA. And then the team count, well, I would just leave that as 2 for the minimum, 2 teams, and maybe 10 as the max. And then for the minimum player count, 2 and 10. So that way we can have up to, yeah, that's right. We can have up to 2 teams, or we start with at least 2 teams, up to 10 teams that are all FFA ones. And then we have, there we go, 1 player per team, up to 10. Actually, no, up to 1. So there we go. That would be 1 person per team with copies of them all. It's very confusing. I get mixed up, and you can adjust it however you want. But I'm going to go with this so that I get 2 people in a team. And I think in my other version, I'll show you the other one, I have them on the same team. So I have 1 team count here. Let's do that. 1 team with a minimum of 2 players and a maximum of 10, and a maximum of just that 1 team. So this would be like a teamed up against the computer FFA, or like 10 players versus PC or versus NPCs. I hit create. and it's, I should say, 2 to 10 players, and that'll create my pool and get everything ready. So that's all I need to get the key part working. Next, we've got to look at backfill, and I want to show you this actually running in action, show you kind of how it works, or show you that it works. All right, let's watch it in action now. So here I've got one instance from a build already running, and we're in the startup scene. I'm going to press play, and it should go into this in progress view so that it's sitting there. It's on the client. There we go. It's in progress, waiting. That's the ticket status right there. If we look right here at the code, that's this on line 56, response equals assignment.status. And now it's just waiting for one of those replies, either for it to time out or for it to connect or fail. So we'll give it just a moment. And if I pull up the dashboard, I should be able to go over to my server section, and I cleaned up that other instance. Let's go to clear the online filter. And there we go, my one test fleet now is booting up. So it's gonna take a moment, and I'm gonna see it probably time out and fail first. That's kind of what I should expect to see. And you're gonna see this whenever you haven't run your server for a while. It's gonna shut down. Again, to save money, you don't wanna just keep running it constantly. And it does take, I don't know exactly the time, but I would give it maybe up to 5 minutes to boot the first time. Once the server's up and running though, or the machine is up and running, the server's come up really fast because they're just Docker containers from what I can tell that are spinning up, and they're really, really quick to start up. But the actual instance here takes a second. There you go. You can see that we actually timed out. We hit that 30 seconds. And if we give it just another few minutes, we should be able to get there. So let's pause the recording. There we go. We've moved ahead one step to a waiting setup. And eventually it's going to be booted, and then it's going to deploy. Oh, look at that. It looks like it already happened. So it connected, and then it looks like we instantly disconnected. Let's go find the Unity window. Yeah, it looks like it instantly disconnected. I'm going to restart it real quick, though. We'll just rerun our client. It's probably a side effect of something else that I had done. And then we relaunch my dedicated server build, or my not dedicated server build, my other client build. There we go, in progress, in progress. It should start connecting them. My expectation is that they will both connect in just a second. So if I go over here to servers, I should see one's allocated there. It's starting up, and then it should connect these players and send them into it. Let's give it a second. It's got the one on port 9000 and the one on port 9100. Oh, it looks like I failed again. I think maybe my allocations were taken up. Let's see. If I refresh, I have it set to a max of 2 servers, and it looks like that's the problem, that it already has them set for somebody else. So let's just stop. Here we go. I'll show you what to do is I just go over here, go to my servers, and find the, oh, it just restarted the new one. There we go. But I don't know why I disconnected. Okay. Oh, I do know why I disconnected. I've updated the server and the client, and they're now out of sync. So let's go take a look at that. I think that's actually a great thing to show. Let's click on the server here. And if I click on the files and I go to the engine log, you're going to run into this, at least if you're using netcode for game objects. You see right down here, where's it at? Oh, this is the wrong one. This is not the one that I connected to. So let's go back. This is 677. Wait, what was the port? 9000. So it should be this one. Oh, it should be that one. Files, int log. Ah, there it is. I missed it the first time. It's right up here at the top. I'm totally blind, but it was this that I was looking for. Network config mismatch. So that's why it didn't connect, just because they were out of sync. So let me do a quick build, but first let's take a look at the backfill thing. Then we'll do a build and wrap all of this up. Now, before we go into the backfill stuff, I just want to quickly mention that if you don't want backfilling in your game, like you've got a League of Legends style game or something else where your teams stay the same from the beginning until the end, then you can just use what you have now. Don't worry about this next part. But if you want to be able to have players come back in and rejoin games and stuff, then this is important. So check it out. It's pretty simple once you get the flow working. Now, there are a couple things to note here. First, right at the top, we need to keep this server object around after we've started our game and jumped over to our level scene. So if we go into level 1, we need to make sure that the server object is around. So we have a don't destroy on load here on line 20. This actually caught me off a couple times. It happens when running on the server and running in Linux. don't realize that, hey, my server object got shut down because it got destroyed. Anyway, let's continue on. So we have our start server method that actually does do one thing for the backfill in line 21. We'll take a look at that in a second. And then on line 22, we have this start coroutine that kicks off an approval that's going to run every second. Let's take a look at the start server part. If we go down to the bottom, you see that right here on the end of start server, after we've kicked off an actual network server, we wait and we do that subscribe to server events async and then call this create backfill ticket. Let's hit F12 and go see what that looks like. Right down here, you'll see that first we get the results from our multiplay service. This is our matchmaking results. And to do this, you have to use the multiplay service get payload allocation from JSON and use this matchmaking results type, which is actually built into the matchmaker library. You can see it right there. And this was one of the things that was a little bit difficult for me to figure out. Found it in some sample code though, and then realized how it works. So I assume that this payload can change and you can have different types of data in there if you want to customize it, but this is the default that we've got here. So we have our matchmaking results, and then on line 87, I do a quick log just to show our connection stuff. This properties actually, I think, just logs out the string or the type, so it's not very useful, but it's nice to know what environment, what the match ID is. Then we have to create a backfill properties where we pass in the match properties of that results, and that's why we need to get this results object so we can pass this match properties in, and we can hit F12 on it. You can go look at all the data for match properties if you want, but I'm going to just kind of skip over it or gloss over it. It's got our teams, though, our players that are in there, the region, and our backfill ticket ID, which is kind of what we're going to need. Let's continue on. On line 92, we have the name of our queue, and I just have it out here as a separate variable just to make it really obvious what this is. So when you're looking at it, just make sure that it matches your queue name. And then a connection string, which is just our IP address and port. It's not really a full connection string like in a typical programming.NET way, but it's just the port or the IP and port that we need to pass in to our options. So we create a backfill ticket options here on line 96. Using that connection string, some attributes where we could do filters that we're going to ignore for now, and the backfill ticket properties. Next, on line 103, we call this create backfill ticket async, which is going to give us back a ticket ID, which is a string that we'll be able to approve every second. And you can see down here on line 106, I have a little countdown just helping me debug log this. You don't actually need a countdown, but if you want to see it kind of wait for the stuff to go, you can have that in there, or you can cut that out. The part that we actually need is really just a while loop that runs, so something that's going to run indefinitely. So while true is just going to be true forever and keep running until we break out or the game ends or this object gets destroyed. We wait for a second. If we have a ticket ID, then we continue on. If we don't have one, well, if we don't have one, we continue the loop and go back and just write a little log. If we do have one, though, we call this approve backfill ticket async method and pass in our ticket ID. All of the rest of this is just logs. You can see like this entire thing could be shrunk down to about 4 lines. You just have lots of logs in here so you can see what's going on when we run it. Now let's try it out. To save some time, I already did the build and deployment, so it's going up there right now, and we'll just wait for this server to come up. As soon as our server boots up again, we'll be able to try it out. All right, there we go. Our client's connected, and I should be able to look at the log on our server real quick and see that it's looking for backfill. So let's just go do a quick check. Scroll down here, got our waiting, and then it's approving backfills constantly. Looks good. Let's go try actually backfilling, running another client. So kick off another multiplay executable. And we should expect this one to join in and become client number 3. Give them just a couple seconds. Couple more seconds. Go check the logs. Oh, there we go. They connected. It took a second. It took a little bit longer than I expected for them to get in, but they did get in, connected, and joined as player 3 before I even got into the log. There we go. So backfill is working. We've got our players connecting, and hopefully this is useful for you and you're able to start building out your own dedicated server games. Again, we're not covering the actual game part for our game here. We've got a simple little script on the player that just sends an RPC, and I'll show you that real quick just for completeness. So we've got our player prefab here, and I'm going to make this whole project available for download too. If you want to download this and try it out, just run it yourself. You'll be able to grab it. I'll put a link down there in the description so you can go grab the entire thing and try it out and just run it on your own. Just make sure that you set up your own project ID, of course. You'll have to do that to make it all work. Here's the player though. It just has a simple game player script on it that sends a test RPC, I believe, in start. So yeah, on start, if we're a client and we're the local player, we send a message to the server, a server RPC that then tells it to send a message back out to the client. Nothing complicated there at all. Again, building your game part is pretty separate from building the server infrastructure, matchmaking, and setup stuff. And I wanted to really just kind of demystify and simplify this as much as possible so that people can figure out all of the steps that kind of caught me off guard while I was going through the process myself. Anyway, if you have thoughts about this or questions or comments, please drop them down in the comments below. I'm open to seeing what other types of stuff we can do here, what things I may have missed, or what things might be better explained. And if you want to learn more about general multiplayer game development, make sure you check out the multiplayer mastery course as well. I'll link that down in the description, or you go to game.courses/MP. All right, thanks again. Don't forget to thumbs up, subscribe, and all that stuff, and I'll see you in the next video.